Welcome Math 10 to your lesson on whole power exponents. So the first part of this lesson is going to be a lot based on a review of grade 9, okay? Then we're going to get into slightly more complicated stuff. So let's start off here with just some simple definitions. Now, what is this whole thing here called? That whole thing here is a power, okay? This whole situation is called a power. Now, what is that little n? That little n is called an exponent. It's superscript. So the superscript number there is always going to be the exponent. And the bottom number, the one that we are multiplying over and over, is my base. So these are three terms that you should know. Okay, and by the end of the class, you will know them no problem, because I'll be reviewing them non-stop. So now let's take a look at our next lesson, or our first few questions. So we want to rewrite and expand each of these as multiplication. Okay, so here we go. We have 3 multiplied by A, multiplied by B, multiplied by B, multiplied by B, multiplied by B. Because right here I look at this, the exponent at 4 only has a base of B. The B is the base, the exponent is 4. 3 and A are not part of the base of that. 3 has its own exponent of 1, and A has its own exponent of 1. Let's take a look at the next one here. If I look at this here, here's my bracket, so that means all of this must be to the exponent 4. So all of this here is the base, this is my exponent, and this whole thing is the power. Whereas before, question above, only that was the power. So this will give me 3AB multiplied by 3AB multiplied by 3AB multiplied by 3AB. Okay? So if I was to do this, this is 3, 1, 2, 3, 4, 1, 2, 3, 4. Oh. So it kind of looks like that if we multiply all of these here together. This little dot means multiplication. Okay? So it looks like that. Now, let's take a look at my next one here. Well, this is, first I'm going to expand what's in the brackets, because we're going to follow the good old trusted bed maths. Okay? So in my brackets, I have 3. Then I have A multiplied by A. Then I'm going to have B multiplied by B multiplied by B. Okay? And I want all of this to the power of 4. So I need 4 of this, because it's saying all of this has an exponent of 4. This is all the base for that exponent. So I'm going to have 3, A, B, B, B. There's 2. 3, A, B, B, B. There's 3. And last one. And there is 4. So looking at this, what rule could we make? Okay, basically, look at this exponent. If there's no brackets, what is it referring to? Here, if we have an exponent, and there's brackets right next to the exponent, what is that referring to? I'll just erase this so it's a little bit clearer. Okay? And the next one here, we have exponents in the brackets, and then that exponent on the outside. How does everything affect each other here? So just expand it and see if you can make some sort of rule. I'll come by tomorrow and check to see if you did it, made that rule, and we'll see what we can do. Let's take a look at this next one here. We have 2 to the power of 4. Well, that's equal to 2 times 2 times 2 times 2, which is the same as 16. The next one is 2 times 2 times 2. 2, base 2, exponent 3, which gives me 8. Now we have base 2, exponent 2, which is 2 times 2, which gives me 2. Oh, sorry, 4. And my last one is base 2, exponent 1, which is 2, which is equal to 2. Now base 2, exponent 0, what does that equal to? I look at this. What's my pattern happening here? I'm dividing by 2 as I go down. Go down here, divide by 2. Go down here, I divide by 2. 4, we go. How do I get to 4? We divide by 2. Divide by 2. Okay? So then what do I have to do to get to the last one? Well, I have to divide by 2. So what's 2 divided by 2? That's going to give me 1. Okay? Well, I'm going to help you with this rule here. It says, what rule can we make? Well, let's take a look at if I use a variable a. So if I have a to the power 4, that's the same as a multiplied by a, multiplied by a, multiplied by a. All right? Now let's take a look at a to the power of 3. Well, that gives me 3 a's multiplied together. If I had a to the power of 2, that is 2 a's multiplied together. If I had a to the power of 1, that's just a. Next one is just going to be a to the power of 0. When I look at this, every time to go from here to here, what's happening? I am dividing by a. Okay? To go from here to here, I divide by a. Go from here to here, I divide by a. So then to go from here to here, I have to divide by a. Okay? Because basically, what's a squared divided by a? A. Because 3 times 3 divided by 3 is 3. Okay? So then here, we divide by a. A divided by a is always 1. So what rule can you make about this? What rule about anything to the power of 0? Okay? Now, I want you to go to page 63 in your book and try and fill out this table here, okay? This part here, I'm going to look it over tomorrow because this is all a review of grade 9 and you need to know this stuff. If you need help with it, I'll help you out with it tomorrow. But make sure you know this table inside and out. I want you to fill out the table on page 63. Okay? Once you're done that, we're going to continue these here. So it says use the exponent laws to simplify the following. Well, I look at this here. This is the same as 3 multiplied by 3 multiplied by 3 multiplied by 3 all multiplied by 3 multiplied by 3. Okay? So altogether I have 1, 2, 3, 4, 5, 6. That's 6 3's. How do I get that? I just add these exponents. That's 3 to the 4 plus 2. That's it. Let's take a look at this next one. This is division. That line just didn't show up. So I want to divide these. Okay? So that's negative 2 multiplied by negative 2 multiplied by negative 2, negative 2 multiplied by negative 2, all over negative 2 multiplied by negative 2 multiplied by negative 2. So I can start canceling these out. 2 divided by 2 is 1. 2 divided by 2 is 1. So that gives me 2 to the power, negative 2 to the power of 2. But I look at this now, that's the same as 5 subtract 3. Oops, 2 to the 5 subtract 3, which is equal to 2 to the negative, or 2 squared, negative 2 squared. Okay? Let's take a look at my next one. This is the power to a power law. So we did product law, we did quotient law. Now we're doing power to a power. Well, this is the same as 5 multiplied by 5, and 5 multiplied by 5, and 5 multiplied by 5. I look this up, 1, 2, 3, 4, 5, 6 5s. Well, what's 2 multiplied by 3? 6. So it's the same as 5, 2 multiplied by 3, which just gives me 5 to the power of 6. Done. Now my last one here, or second last one, we have again the product law. Okay? But we have a complication. We have variables. So that's just going to be a to the 4 plus 3, which gives me a to the 7. Because anytime we multiply, they're the same bases, and we multiply them together, we just add the exponents. Okay? Next one is y to the power of 5. This is power to a power. So that's going to be y to the 5 times 5, which gives me y to the 25. That's it. Because I have y to the 5, and I have 5 groups of just this. So it's going to be 5 y's, and another 5 groups of that is, 5 groups of 5 is 25. Okay?